All right, welcome. So today what I want to do is I want to talk about some things in starting with trig. I know a lot of students, when they begin trig, in my experience of tutoring, that they kind of get buried in the first half of the semester because in contrast to the pre-calc they had last semester, there's a lot of newer things. There's some familiar things. There's SOHCAHTOA and just general angles and triangles, but there's a lot of newer things in there, and they throw so much at you in the beginning that I think it really benefits students when they're taking a little bit of time before the semester begins just to go over some things, just to make sure that they're kind of clear on what some of those things mean when I talk about radians, or when I talk about sine, cosine, tangent, and have a real clear understanding of what that is. Because if you don't, then what happens is near the end of the semester, the second half, they expect you to know it, and if you don't, you're going to get lost. So we want to be quick on these things. So that's my hope, is that in this video I'm going to show you some things that might help. Okay, so looking at this here, we have this trigonometry. I call it chapter 4. Some books begin in different chapters, but this will be applicable, I think, to anyone who's taken trig. Okay, so the first things that I would say is, well, I have listed 4 things here, and I bullet point them. The first one is I want you to be able to define and explain what a radian is. So that'll be one of our, I guess, a vocab word you could say at the beginning here. So I'm going to try to do this, each of these 4 bullet points in one video each. That's my hope. So today I'm going to talk about that first one, be able to define a radian. And then the second thing I want you to be able to do is be able to convert from degrees to radians, because they're both angle measures. So we're very familiar with degrees. I think the sooner you can get familiar with radians and you feel comfortable with it, the better, because most books, they tend to go heavier on the radians than the degrees. So that's a big point. I think it makes sure you be able to feel comfortable with radians, but we want to be able to convert back and forth if we need to. The third thing is be able to draw a unit circle and be able to identify the positions of these angles. These are angles here. This little symbol here is a Greek letter theta, and when we talk about angles, they'll tend to use that in a lot of textbooks. Sometimes they'll use X, but I think theta is better. We'll see that a lot. So theta, these different angles, these are angles. The angle of 0, pi over 6, pi over 4, pi over 3, pi over 2, pi and 2 pi, and those are all in radians. So we want to be able to draw the unit circle and go, oh, that's pi over 3, that's pi over 4, and so on. Okay, familiarize yourself with the x, cosine, and y sine values of each of those angles that I listed above, the 0, pi over 6, pi, and so on. So we want to be able to say, oh, if what's the sine of pi over 6? You go, oh, and you'll know exactly what it is. So that's my hope by the 4th video. Okay, so let's go right on ahead to this first part here, which is be able to define what a radian is. So a radian, it's an angle measure. So theta, radian angle measure. Like I said, I'll use theta as the variable for when we're talking about angle measures. An angle measure, and I think the best way to explain to somebody what a radian is, if they ask you, is you say, well, give me a circle, and then you say, and tell me what you want the radius to be. And they might say, for example, let's just make it 3 inches, okay? So what you'll reply then, if they ask you what is a radian, you go, well, imagine that I make an arc length of that same distance of 3 inches, okay? So this is also going to be 3 inches. Remember, the arc is like on the outside of the circle. Then this angle inside of here will be 1 radian. Okay, so really what you're saying is that the arc length and the radius are the same. Okay, and what if they say, well, what if it's 2 radians? What if I want to measure 2 radians around? Then you go, oh, well, it's simple. It's going to be 6 inches now. Okay, so that'd be 2 radians. This would be like an additional radian over here, an additional 1 rad. They'll often shorten it to rad, 1 radian. Okay, so a natural question might be like, well, how many radians does it take to make one complete circle, right? So if you think about this, I think it'll make sense that if you're talking about traversing the outside of a circle, if you go around one full time, there's a word we give that in geometry. If it's like you think about the word perimeter, the perimeter of a circle is the circumference. So one circle has a circumference, right? And then if we recall the formula for the circumference formula is 2 pi r, okay? All right, so if we take this circle, and if we suppose that we have just a radius of 1, just to simplify things, right? I'll say 1, and it could be unitless. It could be 1, whatever you like. But if I take this to be 1, then that means the circumference of this thing, you know, traversing the whole outside of it, you know, going around the perimeter, if you will, the circumference would be 2 pi times 1, which is really 2 pi, right? If you go around one time in that circle, it'd be a distance of 2 pi. So that means that if you have a theta, an angle of 2 pi, well, that's going all the way around once, because an arc length is 2 pi, okay, if the radius is 1, and that means therefore that the theta would be 2 pi. So that if you're talking about 2 pi radians, you're talking about one full circle going around one time on a circle. That's the angle. Okay, all right. So there's a formula that kind of ties these ideas in. Again, like arc length, the theta in radians, and then r, and it's going to look like this. It's going to be S is equal to theta. That's the angle measure times r. So it's kind of easy to remember. It's just like S is equal to theta r, or I like to call it the SOR formula, even though it's not really an R. I mean, it's not really an O, sorry. SOR formula. Okay, so I'll pull out a problem here. Like, what if that they'll throw at you at the beginning here? They might say, hey, if I have a theta of, let's say, pi over 6, and then you want to get used to these pi things, because radians, they tend to give it in pi's. Pi over 6, and I have a radius of, let's say, 7 feet. They might ask, what is S? What is the arc length? You know, you imagine this. Sketching things out, I think, in trigonometry helps a lot. They're saying, hey, if you have a circle, it's got 7 feet is the radius, and you have pi over 6 is the angle. Let's say it's like right here. That's your pi over 6. What is this length right here? What is this arc length? Well, it's pretty simple. We just use the formula. We just say S is equal to theta, which is pi over 6, times the radius, which is 7. And you just do the math there. And well, typically you'd leave these things in terms of pi. So I'm just going to write like this, 7 pi over 6 feet. It'll retain the same units as the radius. So I get to say, oh, the arc length is this. Okay. Or similarly, if they could ask, okay, if they give you, you know, I'll write my formula again, just so I have it handy. S is equal to theta r. If they ask us, okay, if you have a circle, and you know what the arc length is, let's say we know what the radius is. Radius is 2 inches, and we have an arc length. Say it's 5 inches. Is that 5 inches? Maybe it'd be more like this. Does that look like 5 inches? And here, I'll connect it here. What would be the theta? They might ask you that. What is theta? Well, pretty easy to do, right? We know S is 5. S is 5 inches. Okay, and then we know R is 2 inches. So we just, plug it in. We're going to solve for theta. So I would do S equals theta R. Probably should use a capital R. Oh well. And then I'm going to divide both sides by R to get theta by itself, right? Because I want to solve for that. So that's all you got to do. You just got to put in, oh, it's going to be 5 over 2. So theta would be 5 over 2. And I would write 5 over 2 radians, or rad for short. And that's my answer. That's the angle. The angle is 5 over 2. So one of the things that's good about radians is that you can often talk in terms of arc lengths, or you can connect it to arc length. So if you're finding out how far along or the outside of a circle, they're much better than degrees in that way, because the formula is so simple here, right? S equals theta r. Right. So the first thing I would do is I would suggest, maybe I'd throw some problems at you, is practice on this to make sure you get this down. All right? Good. Excellent. Have a good one. Bye.